Welcome to the SciCon Machine Learning Tool tutorial. Today we are going to be covering support vector regression, or SVR. Let's cover a brief introduction to support vector machine, which is a machine learning model that predicts values by analyzing data and recognizing patterns. It tries to find the particular line, called a hyperplane, that maximally separates different classes within the data. It is a supervised learning algorithm, meaning that the model is trained on label data and learns through comparing its predictions to the actual values. There are two types of support vector machine: support vector classifier, or SVC, and support vector regression, or SVR, which is what we are covering in this tutorial. The goal of support vector regression is to find a function, f of x, that best predicts the continuous output value for some given input value. It attempts to minimize prediction error, or E, which is the difference between the prediction and true label. It uses error-insensitive loss functions, which penalizes predictions farther than the error value from the desired output. Now let's cover a little bit about hyperplanes. A hyperplane is a plane that divides data points into categories based on their values. In linear regression, this is simply a line. Support vectors are points close to the hyperplane that help determine its orientation. Acceptable predictions fall between the positive and negative hyperplanes, otherwise known as the error tube. This model is commonly evaluated using mean absolute error, or MAE. It is the measure of the average absolute difference between the predictions and actual values, and is calculated using this equation, where yi is the predicted value, xi is the actual value from the dataset, and n is the number of points within the data. It treats overestimations or underestimations the same, which makes it a good choice when error direction isn't important. A small mean absolute error value means that the model is a good fit for the data. For our example today, we are going to be using phytomining data, so let's just cover briefly what that is. Phytomining is the cultivation of special plant species with the goal of harvesting them to obtain metals from soil. Ideal plants used in this process are those that produce high amounts of biomass and have high tissue metal concentrations. This is the SciCon machine learning tool interface. I'm going to start with adding my project name and a short description talking about how I will be using this interface to perform support vector regression using experimental phytomining data. I will start with selecting my data type. I'm using a CSV file, so I'm going to select tabular. I've already uploaded my phytomining test data, and that's shown in this table here. There are two columns: my dry plant mass in grams and the total rare earth element concentration within the plant mass in micrograms per gram. For my target label, I'm going to select dry mass as my dependent variable. Then I am going to select machine learning algorithm as my method. I am going to select SVR for my algorithm class. And for my evaluation metric, I am going to go ahead and select MAE. Then I'm going to click Perform. So these are my evaluation results, complete with the mean absolute error here. The red dots show the y-test data from the actual data set, and the blue line represents the predicted values that the model has come up with. These values are also included within these y-test and y-prediction columns. This has been the SciCon machine learning tool tutorial for support vector regression. Thank you for watching.